you to Professor Fortunado for allowing me to make up my assignment for part one of test three. Okay, so let's begin. So we have 1,000 kilogram car is in motion north on Morewood Avenue at a speed of 15 meters per second. At the intersection of Morewood and Fifth Avenue, it collides with a truck, white mass, sorry, of 2,000 kilograms that is traveling east Fifth Avenue at 10 meters per second. Treat each vehicle as a particle. Find the total momentum, magnitude, and direction just before the collision. Okay, so it wants us to find exactly what it said. The momentum before the collision. So they want to know like basically the angle and how fast the car was moving. And the way we can find this is by breaking it down into two parts. And I'm going to start first with the speed, right? How fast it's going before I do the direction. So we have Px is equal to PAX plus PBX. Now it's going to be the same thing for PY, just PAY plus PBY. This will allow us to help us with how fast it's moving and the direction it's going, right? So if I clear this, we can do a drawing, right? One is heading northbound, right? And we can say that's PA, and then one is heading to the right, which is PB. And this is X, and this is the Y. And we can find that the total direction that they're going. Y up, by the way, is going to be north, just to keep track of it. Okay, let's begin the calculations now. We could figure out that PAX, right? If we do the math quickly, it's MA times VAX, which is the mass times the initial velocity. And it's going to be 1,000 kilograms, right? We have the kg times 0, which is going to be 0, right? And then the PB is going to be 2,000 times VBX. We don't know it exactly, right? They didn't really tell us. So it's going to be 2,000 times unknown. I'm going to put X. So we can practically solve this after we add it together from the first equation, and we're going to be left with 2,000 VBX. I'm so sorry for the cough. Next up is the PYs, right? After we solve for the BYs, we can figure out that PY is going to be, we got to break it down again. So the PAY is be equal to the MA times VAX again. But this time, it's 1,000 kilograms times the 20 meters per second, right? This is going to leave us with this number right here, 20,000 kilograms per second, right? After we do that, we do the same equation for MB times VBX, but this time with a Y, and this time it'll be 0 because we know that the Y this time is 0, right? From the problem. So it's 2,000 times 0, and we're essentially going back to the original, which is just going to be 20,000 plus 0 equals to 20,000. Right? Let's just put 20,000. Let's just imagine the 20,000 is a kg meters per second. Sorry. Now we're not done yet. We can figure out the total momentum, and we can figure out the total angle as well. So if we do now Py over Px, right, to figure out the exact location, that's going to turn into 20,000, right? We said originally, over to 2,000, and this is kilograms per meter per second, just to remind y'all. And that's just going to equate down to practically 20 meters per second. you might you might get a more specific calculation depending on how you do these calculations, but it should be about 20 meters per second. And then we could figure that out by putting in, sorry, the tan, right? Tan angle of, right, which is going to be the tan inverse of 1 over PT and PC we spoke of, and it's going to be 36.87 degrees, which is about 30 degrees. So our answers are going to be 20 meters per second, right, at a 30-degree angle. That PA on the Y and PB on the X are going to meet up. Thank you.